Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. How are you all? Hope that you all are well, children. Okay, today we are going to study a new topic which I discussed in my previous video, and that was addition of binary numbers. That is logical binary shift. By the way, what comes to your mind when you talk about the shifting? I'm just concentrating on the words that we should be aware of. Just to remember the concept, shifting means moving, exactly. Now, if I say like shifting your home or shifting your school or whatever, so here what we mean is we are given a binary number and we will learn what is the effect if the binary value is shifted by a number, which is going to be a value which is discussed here, which is going to be either on the left-hand side or on the right-hand side. Now, just remember, my binary value is going to be composed of 8 bits. And if I'm asked to shift those values, either one place or two place or three place to the left or to the right, then what is the impact? What happens to that value? This is what we are learning. And you can see here, each shift left, each one shift, two shift, three shift. That is what is being meant here. Each shift towards the left-hand side means the binary value will be multiplied by 2. If it's shifting left twice, it means it will be multiplied by, yes, what do you think? Quick. I said each shift left means multiplying the binary number by 2. So what do you think will be the effect if the value is shifted 2 places to the left? Multiplication, correct? Multiplication by 2 to the power 2, that is 4. That's great. If the same value is shifted 3 places to the left, then multiplication by 6 or 8. Yes, that's correct. It should be 2 to the power 3. That means it will be 2 into 2 into 2. That will be 8. So just remember this very simple principle. Each shift left means multiplying the value by 2 by the powers of 2. 2 to the power 1, 2 to the power 2, 2 to the power 3. In this manner, the value will be increasing based on the number of shifts that have taken place. On the contrary, if I am asked to perform shifting towards the right-hand side, then it will be the reverse process. And the reverse process is, as you know in math, it's going to be division and dividing the binary number by 2 if it's one shift, dividing the binary number by 4 if it is shifting twice or 2 numbers are shifted, dividing the binary number by 8 if it's shifting by 3 places. In this manner, you can see it's always going to be in the powers of 2. One shift means 2 to the power 1, 2 shift means 2 to the power 2, 3 shift means 2 to the power 3. In this manner, the value will be increasing in this manner. Fine, are you clear? Just remember, left shift means multiplying and right shift means dividing. Just let's make a shortcut. I hope that we all can remember. LM, left shift means multiplying, or RD, right shift means dividing. A simple rule to remember the things. I hope that will help us in remembering. LM for left shift multiplying and RD, right shift dividing. Now, we are actually moving on to the concept of what happens, and before we actually perform any activity, one thing that we need to be aware of is when bits are shifted, one very important thing, when bits are shifted, all the empty positions are replaced with a 0. No matter whether the shifting was of a 0 or a 1, just remember they're always going to be storing the value of a 0 there. And best one caution is there's a limit to the number of shifts that can take place. I can't perform shifting and still I'll be getting the same as I talked about. Left shift means multiplication, and the answer may not come accurate because there is a limit to the number of shifts that can happen. Now you can see if the binary number is stored in an 8-bit register, eventually after a number of shifts have taken place, then it may occur that all the values are lost and only the whole byte is composed of zeros, And just think, what do you think? Will it be a good option? Will it be correct answer? No, definitely not. As an example is given to you, if you talk about this example, and okay, now I'm saying it from the left-hand side. And if you remember, by the way, just remember the term that we have learned, the leftmost bit is, will you recall? The leftmost is basically the LSB or MSB. More significant, yes, correct, MSB, more significant bit. And on the contrary, the bit that is on the extreme right hand side is your LSB, the significant bit. Now if I talk about this value 0 1 1 1 and then 4 zeros, and if you calculate the equivalent value is binary value is going to be 1 1 2. If I say I'm performing the left shift, and which means 2 to the power 5 or multiplied by 32, so you can see if I'm performing left shift but 5 times, then it would end up with zeros in the entire register. If you just see in the entire byte, it's composed of all zeros. Is it correct? By the way, 112 multiplied by 32, is it 0? Definitely not. And this is what you need to understand, that there's a limit to the number of shifts that can happen, and your answer will be, as we have learned, left shift means multiplying by 2 or powers of 2, and right shift means dividing by powers of 2. Fine, be cautious about it. You can get a question regarding this also. Now, just a question to handle. How is it being handled? Now you can see the denary number 21, its equivalent binary value, as you can see, I'm saying it from the MSB, which is on the leftmost side, and 000010101. If I am asked to shift the value one place to the left, so you can see this leftmost bit that is present on location number 128 will be moving out of the byte, and then 64 will move to this location. You can see this is how it will happen. This value 64 is going to move to this location. The value 32 will move to 64. The value that was present on this location will move to 32. Then 8 will move on 16. Then 4 will move on 8. And then 0 will move here. And this 1 that was present on this location will move on to this location. And this location that was empty will be padded with a 0. I hope that we all are clear. Remember, please, that the empty locations are padded with a 0. And if you perform the, you can say, conversion, you can see for yourself that the answer is going to be 42, like 32 plus 8 plus 2 gives you 42, which is the correct answer, because 21 multiplied by 2 to the power 1 is equal to 42. And up till now, it's correct because it's something that is possible. One shift results in the value that is giving you the absolute answer. Any ambiguities, any questions? Yes, student, before I move on to the next, I can say part, are you all okay with the one shifting resulting in each bit, like leftmost bit moving out of the byte, and each value is shifted one place to the left? Assume in such a manner that I ask you people to do the same in the physical class also. So the same thing will happen, that you are going to just move your places, you're going to move your locations, and this is what is going to happen here. Now moving on to the next example. Now, the original number is now shifted 2 places to the left. You can see the original number was 000100101. So if it is now moved 2 places to the left, so what will happen? These 2 bits will be lost, and this 0 will come here, then 10101, and the empty locations will be padded with a 0. You can see, and please remember, this is not the 0 that has moved out of the byte. This is just the 0 that is coming in place. Are you clear? And you can see for yourself, if you calculate, it's going to be 64 plus 16 plus 4 is going to give you the answer as 84, which is the correct answer, because you can see 21 multiplied by 2 to the power 2 or 21 multiplied by 4 is actually 84. Till now, your answer is correct. You can see 21 into 2, correct answer 42. 21 into 4, again correct answer 84. Now let's move on to, if the same byte, which is 21 000 is asked to be shifted 3 places to the left. So what will happen? Yes. What comes to your mind? What will happen now? Yes, correct. These 3 bits will be moving out of the byte. They will be moving out, and this one is now is now going to move on to this location 10101, and the empty locations are going to be can say padded with zeros. And you can see again till now the answer is correct, because 21 into 2 to the power 3 or 21 into 8 is 168, which is still the correct answer. Till now, any ambiguity? What we did? Original number 21 was shifted 1 place to the left. We observed the impact was, the result was 42, correct. Then the same original 21 was shifted one more place, like 2 places, and I can see the answer is again correct. 3 places, still the answer is correct. It is resulting into 21 into 2 to the power 3 or 21 into 8, and it's 168. And you can see for yourself that the answer is matching with the byte value. Till now it's correct. But if we are asked to shift this original number, just 000100101, 4 places. So in this case, you can see for yourself that it means 1, 2, 3, 4. These 4 bits will be lost, and this now includes 1 also. And please be very cautious. Losing this 1 from the byte does not mean, so what will happen? This 0 will come here. Now you will have 0101, which is this value, and the empty locations, the 4 empty locations are now going to have 0000. Clear? Now, in this case, the leftmost bit, the LSB1 is lost. It's not the same. By the way, is the answer correct? We are expecting that if we are performing shift 4 times, it should be 2 to the power 4. But is it resulting in an answer which is 21 into 2 to the power 4, which is 21 into 16? Is 21 into 16 the same answer as we are getting? 64 plus 16? Is it the same? 64 plus 16, what is it? 80. Yes. Is 80 the right answer? 21 into 16, is it 80? Never. It means that you can see for yourself that there's a limit, what we discussed in the beginning, that there's a limit to the number of shifts that can result in a correct answer. I mean, just remember this: when you have exceeded the maximum number of left shifts possible, then that results in an error in your byte. Any questions? Okay, definitely we'll be doing an activity, but before I move on to the activity, let's do very quickly the right shift also. Is anyone having any question regarding left shift? Okay. Now right shift. What was right shift doing? Multiplication or division? RD. Yes, division. That's great. Now this is another question. We have taken example of a denary number 200, and you can see for yourself the denary number 200 is going to result in 128. Value 128 is a 1, then 64 is a 1, and then 8 is a 1. 128 plus 64 plus 8 gives you the value 200. Now, in this case, if I'm asked to perform the bits 1 place to the right, so what will happen? Now you can see it is going to result in bits moving out from here. So 1 place right means that this bit will be lost. This 0 will come here. This 0 will come here. This 1 will come here. 0 will come on this position, 32 will come on 16, 64 will come on 32, 128 will come on 64. Every single bit in the byte will be shifted 1 place to the right, and since there is no place for this position 1, that's why this bit will be lost, will be moving out of the byte, or the LSB, least significant bit, will be moving out of the byte, and now it will be including a 0 here in the empty position. Are you all clear? The right shift clear? Okay, that's great. Now performing the right shift twice. You can see for yourself the value 200 that we have talked about right now. Now we are performing right shift twice. So again, you can see the original number is now shifted. Every single bit is going to move one place to the right hand side. It means the extreme right hand side 2 bits will be lost. The zeros with that were there. And it results in answer as 0, 1. And okay, now I'm saying it from the left. LSB, the significant bit. 0, 1, 0, 0, 1, 1. And the implications will be padded with a 0. Any questions? Is it clear? I can see 200 is going to be divided by 2. And you can see for yourself, the answer is still correct because 32 plus 16 plus 2 gives you the answer at 50. And the same answer is coming here. Now, another one, the way we shifted for the left shifting we did on the entire value. So same case goes here. Let's do this for the third bit also. Now, we are asked to perform the right shift on 3 numbers like thrice. So what will happen now? 3 places to the right means it will be, again, I'm saying it from this side. Okay, now let's take this example. If I'm performing one more shift, it means this one will come here. This 0 will come here. So it will be 1, 0, 0, 1, 1. 1, 0, 0, 1, 1. And the empty locations will be including a 0 here. Again, the same thing. These zeros are not coming from the lost values. They are simply included here. So till now, also you can see for yourself, 16 plus 8 is going to give you 20, 16 plus 8 plus 1 is going to give you 25, which is again correct because 200 divided by 8 is going to give you the same answer. 2 to the power 3 is going to be 8. Clear to everyone? Any questions, any ambiguity? With one shift, we observed that the value 200 was divided by 2, that became 100. We performed the shift once again. It was 100 divided by 2 that made it 50. We performed one shift again that resulted in the value becoming 25. So till now, the answer is coming as a correct answer. Any questions? Now, if I talk about, now we are performing the shift 4 times. So what will happen? In this case, this one will be lost. It means it will be 0, 0, 1, 1, and then all zeros. By the way, what is this answer? With 4 shift, we are assuming it will be divided by 2 to the power 4. That means 16. So 200 divided by 16 should give you a value that is not denoted here. Definitely, it's not 12. Actually, it is going to be something different. So it means that this bit is lost. And in this case, our answer is completely incorrect because it has again exceeded the maximum number of try shifts which are possible. So you can see for yourself, there's a limit to the number of shifts that can happen, either left-hand side or the right-hand side. Again, please remember this, okay? Now, moving on to the activity. If there's no ambiguity, no questions, let's see what the activity is. This is the activity. The first one is you are asked to write down the denary value of the following binary number. Then you have to shift the binary number 3 places to the right, and then you have to comment and you have to tell what is the impact. Then you have to write down the denary value for the following number, and then you have to shift it 4 places to the left and save the impact also. Come on, your time starts now. Okay, are you all able to do it? Any questions? Anyone has any query? Very quickly do it. I'm giving you 3 more minutes, and then we will discuss the answer. You can self-correct your answers, that whether they are correct or not. Yes, are we all done? Now let's compare our answers. The first part, A, denary value is going to be, you can see 1, 2, 4 are zeros, 8, 16 is a zero, then 32, and then 64. And just a tip, 64 plus 32. Just remember that 64 plus 32 gives you 96. That's great. So just remember this tip. That will help you a lot in when doing the work faster. And then the denary value is going to be 64 plus 32 plus 8 gives you 104. Correct answer? Okay, that's great. Now this value is shifted 3 places to the right. It means that these 3 bits will be lost. And what is the new value you can see for yourself? It will be the one that is present on the fourth location will come to the first location. It will be 10110. And then the empty location will be added with a 0. So if I find out the answer is going to be 13, and this is actually 104 divided by 8, which is 2 to the power 3. And you can see for yourself that the answer is coming accurate. Till now, it's completely accurate. Now, so it means that B part is also correctly handled by nearly all of us, isn't it? Have you all got the same answer for parts A and B? Great. Now moving on to part C, right? The denary value of the following binary number, it's a very simple one. 1111, we have learned it so well. We have been practicing this in different questions. So we know it's 15. And when I am asked to perform 4 places to the left, it means these ones will move from these locations to like MSB. It will be 1111. I'm saying it from the MSB side. And then the implications will be padded with zeros. So you can see the answer is 240, which is 15, original number, multiplied by 16, that is 2 to the power 4. So any questions? I hope that we all have got the right answer. Yes, that's great. That's wonderful. Now move on to the next activity. Are we ready? Okay, activity number 2. Now, this one is including, you can say, if you get such a question in the paper, then you will be actually getting, I can say, maybe a few marks for conversion from denary to binary. The denary numbers are 29 and 51. You first of all have to convert them into an 8-bit binary number. Then you have to perform addition of binary also. So it means that this question is actually a revision of a lot of topics that you have covered earlier. And shift the results in B 3 places to the right. Then part D is convert 75 to an 8-bit binary number. Now you have to add the answers from parts C and D. And then what the answer you have obtained in E will be shifted 1 place to the left. Come on, your time starts now. We will discuss the answers once we are done with all the, when all of us are done with the question. Are 5 minutes enough? Okay, just try it out. Any problem anyone is facing? Are we all in the process? Yes, Sharon, any questions? Please write in the chat if you have any queries, if you have any problem in answering any of the parts. Okay, now that's great. You are nearly done till 4. The D part, that's wonderful. Okay, now can I share the answers? Yes, children. May I move ahead with sharing the answers? So you can do the self-correction. Okay. See, it's so simple. 29 is very simple. 16 plus 8 plus 4 plus 1 is 29. And 51, the binary again is very simple. It will be 1 plus 2, then 16, and then 32. 32 plus 16 plus 2 plus 1. Now, if you are performing the addition, we have added 0, 0, 0, 1, 1, 1, 0, 1 with 0, 0, 0, 1, 1, 0, 0, double 1. So what you received as the answer of addition was 0, 1, 0, 1, and then 4 zeros. Is it the same answer obtained by all of us? Till part B, we all are correct? And that's simple. That's great. By the way, with addition, what else have we done? Who can recall the term that we have talked about, that addition of two numbers may result in an error? Can you recall? Okay, now just a hint. It starts with the letter O. That's great. Wonderful, Ali. It's an overflow error. So you can see, by the way, this is not resulting in an overflow error, just a sort of a revision that we need to know that overflow error is caused here. Then if I am asked to perform the result of 3 places to the right, you can see the extreme 3 values are lost, and what you obtain is going to be these 3 values are lost. These 3 bits are lost. And what you obtain is going to be 0, 1, 0, 1, 0. And then the locations are again padded with zeros. So I hope that we all are on the same answer till part C. Now converting 75, again, a very simple thing, 0, 1, 0, 0, 1, 0, 1, 1 is your 75. And then you're going to add the 2 binary numbers which are present in C and D. And what you obtain is part E, and then which is 0, 1, 0, 1, 0, 1, 0, 1. See, such an interesting number. Then you're performing the left shift. And with this left shift, what happens is this bit is lost, and you are going to get 1, 0, 1, 0, 1, 0, 1. And then the LSB will be containing a 0. Are you all clear? Any questions? Any ambiguities? That's great. It was an interesting task. Okay, thank you, Asan. Thank you for motivating me. And that's wonderful that you have understood this topic well. It's interesting also. That's wonderful. Okay, now that's a great class. Thank you for being a part of the journey. Jazakallah khairan kasira. Allah Hafiz. If you have liked my videos, please subscribe my channel and share it with your friends and family so they all are going to benefit from it. More videos will be coming, inshallah, very soon. And the next topic that I'll be discussing with you people will be the two's complement. So stay tuned, share, so that we all are going to learn, we all are going to benefit, and we all are going to do something good for the computer, for the computer family, IT family. Okay, Allah Hafiz once again.